Hello everyone, welcome back to RareChem Official. Today we are going to discuss about quantum numbers. Quantum numbers are required for the complete explanation of electrons in an atom. If take any atom consists of nucleus surrounded by cells. These are the cells KLMN or 1, 2, 3, 4. In previous videos already we discussed position and momentum of an electron. We can't find out exactly, but we can find out the probability of an electron according to Heisenberg's uncertainty principle. But where we can find out the probability of an electron means, see, these are cells again divided into subcells divided into orbitals. In orbitals we can find out the probability of an electron. Principal quantum number, first one is principal quantum number. It was proposed by Niels Bohr. The n values are denoted as 1, 2, 3, 4 or KLMN, etc. When n value increases, size and energy of an orbit increases. These are cells or orbits. If n value increases, size and energy of an orbit increases. If take k or first orbit, size and energy is lesser than second orbit, then third orbit, then fourth orbit, like that it will be there. See, the maximum number of electrons in an orbit equals to 2n square. Total number of orbitals equals to n square. Here these are the orbits or cells. If you want to calculate number of orbitals in orbit equals to n square. If you want to calculate orbitals in first orbit, it is equals to 1 square, means 1. If you want to calculate number of orbitals in second orbit, 2 square, means 4. Like that we can calculate the orbitals in orbit. Our angular momentum of an electron in orbit equals to nh by 25. Second one is azimuthal quantum number denoted by L. It was proposed by Sommerfeld. The values depends on principal quantum number. The values are ranges from 0 to n minus 1. The values of L represents various subcells. It means that if L value is equals to 0, it is s orbital. When L value equals to 1, that is p orbital, 2 d orbital, 3 f orbital respectively. The energies are in the order of s is less than p, less than d, less than f in a given orbit. Already we discussed that n equals to 1, 2, 3, 4. These are the orbits. When when n value increases, size and energy of an orbit increases. Already we discussed. So energies are in the order of sp df in a given orbit. It indicates the shape of an orbital and angular momentum of an electron. If L value equals to 0, that indicates s orbital. The shape of s orbital is spherical. If L value equals to 1, that is p orbital. The shape of p orbital is dumbbell. If L value equals to 2, that is d orbital. The shape of d orbital is double dumbbell. The azimuthal quantum numbers indicates the shape of an orbital and angular momentum of electron. Total number of subcells in a cell equals to n. If it means that n value equals to 1s subcell. Here n value is 1. Here one subcell is present. Here n value is 2. 2 subcells are present. 3 subcells are present. It means that number of subcells equals to n value. 3 means 3 subcells are present. If n value is equals to 1, L value is 0. 0 means s orbital. it is 1, n principal quantum number is 1. So n value is 2. If n value is 2, L value is 0. 0 means s orbital, n means 2. 2 means 2, it is principal quantum number, 2s orbital. Like that we can find out the subcell. Means here 3 means 3 subcells are present, 2 means d orbital, 3 is the principal quantum number. Angular momentum of an electron in a orbital, in principal quantum number we can find out the angular momentum of an electron in a orbit. Here angular momentum of an electron in a orbital equals to h by 2p root of L into L plus 1 equals to h cross h bar root of L into L plus 1. H is the Planck's constant number, Planck's constant. L is the azimuthal quantum number. Next one is magnetic quantum number. It is denoted by M. It was proposed by Landé. The values of L, M ranges from +1 to -1. The values of M depends on azimuthal quantum number. Total M values equals to 2L plus 1. Magnetic quantum number depends on L value, right? If L value equals to 0, M value is 2L plus 1, right? 2 into 0, it is equals to 1, means 1 M value. If L equals to 1, 2 into 1 plus 1, 3, right? So 3 plus 1 minus 1, 0. Plus 1 to minus 1. If L value equals to 1, higher value is plus 1, lower value is minus 1. And the M values, how many M values are here? 3. So M values are 3. If L value equals to 2, 2 into 2 plus 1 equals to 5. Like that we can calculate the M values. The total number of M values indicates the number of orbitals in the subcell. The number of orbitals in sp, df, G and H subcells 1, 3, 5, 7, 9, 11 respectively. It means that if L value equals to 1, M values are here. To calculate M values, the formula is 2L plus 1, right? If L value is 0, 0 plus 1 equals to 2 into 0 plus 1 equals to 1. The M value is 1 for L 0 of 0 L value. 3 for when 3 M values are 3 M values for when L equals to 1. Like that. So if L value equals to 1, that is p orbital. The M values, the M value is 3. The higher value is plus 1 and lower value is minus 1. When L value equals to 2, the higher value is plus 2, lower value is minus 2. When L equals to 3, plus higher value is plus 3, lower value is minus 3. The M values are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 7 for 5, 7 for F, 5 for D. If you want to calculate by using formula 2L plus 1, right? For F, for L value equals to, when L value equals to 3, 2 into 3 plus 1 equals to 7. the 7m values for when L equals to 3. 1, 2, 3, 4, 5, 6, 7, like that. Spin quantum number. It was proposed by Goldsmith and Uhlenbeck. The values of spin quantum numbers are independent. In magnetic quantum number, azimuthal quantum number, they are dependent, but spin quantum number is independent. The values of m are plus half and minus half. For each value of m, there can be two s values. It indicates the direction of spin of an electron. Clockwise spin is represented by plus half and anti-clockwise denoted by minus half. Total spin equals to n by 2. Here n is the number of unpaired electrons. To calculate the spin angular momentum of the electron, h equals to h by 25 root of s into s plus 1. S is the total spin. That's all for today. Thank you for watching. If you like this video, please like, share and subscribe.